I'd like to introduce to you Eleni Margariti from the University of Strathclyde. And Eleni's talk is entitled Advancing Micro-LED Manufacturing, Overcoming Mass Transfer Challenges and Cost Barriers with Continuous Roll Transfer Printing. Thank you.
Okay, thank you, Simon, for the introduction. Hello, everyone. I'm Eleni Margariti, and I am a research scientist at the University of Strathclyde on the Institute of Photonics. So in our institute, we have been deeply involved in micro-LED research, starting from individual micro-LEDs and going back to large-scale manufacturing. Today, I'm excited to share with you a new method that I have developed, which is related to the mass transfer of micro-LEDs, which I think that it could potentially contribute a lot to the mass commercialization of these displays. Okay, I think that we have seen many presentations talking a lot about why micro-LEDs are considered the next generation display technology. So I don't want to stay a lot on this slide, but I will just do like a little bit introduction just for the purpose of my presentation. So micro-LEDs are at the forefront of display technology due to their unmatched brightness, exceptional contrast, and energy efficiency. However, despite their significant benefits, there is still one challenge: how we can actually transfer efficiently a huge amount of tiny LEDs to the backplane of the electronics. This challenge is very important for the large production of these displays, but yet it has been proven that it is a bottleneck for the commercialization of this. So in our institute, as I mentioned before, we cover a wide range of applications and micro-LED research. So we are working also on applications that we are using micro-LEDs for quantum imaging and sensing, and also for visible light communications. But for the purpose of this presentation, I'm just going to focus more on the work that is more relevant to the display part. So we are working on the fundamental physics of micro-LEDs, and we are working also in providing some innovations in LED efficiency. And then there is also a group, it's one of the groups that I'm working on, which we are working a lot on the integration techniques, which essentially this one covers the part how we can take individual micro-LEDs and integrate it to a wide range of platforms and different substrates, or either to CMOS drivers. Which for this one, we are talking about individual components that we integrate them in actual photonic devices for the purpose of any application. Another part is also the fabrication of micro-LED pixels, which, okay, because we are talking about this integration and their integration in different substrates, there is in general a need that you need to have your devices releasable from the native substrate in order to be able to pick them up and print them to the target platform that you want. So another part that I'm working on is also how we can optimize the geometries and the position and the shape of these tethers that we have there, when the devices are suspended, in order to be able to make the pickup essentially easier. So, yes, all these are great, and okay, it works on the purpose of the research environment, and when we want actually to, as I mentioned before, pick individual devices and place them in functional photonic systems, and it works fine. But then the challenge that we have alongside the wide industry is how we can actually scale this up. And in the purpose of micro-LED displays, we are talking about millions of devices. Each of these, okay, depending on the application, but let's say on average 20 micrometers in size, that need to be pitch matched to the electronics that are printed to. Now, the greatest challenge in order to enter the mass production is how to take a huge amount of these devices and place them to the target surface or circuit with high precision. But let's see where we are at the moment. There have been several mass transfer techniques that have been proposed. Some of these we have already seen some wonderful presentations during the last 2 days, which they work in terms of accuracy and yield. However, they still have a challenge, and the main challenge is related with the cost. And that comes from two different parts. The one is that they have to use some costly equipment to do that. And the other part is that they used to have an external driven force in order to do the printing. Either it is laser assisted or electrostatic or, yes, fluid transfer, let's say, for example. So effectively, what we need is a method in order to do this transfer, but first, This method should be compatible with the existing manufacturing process flows in order